One. 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 Okay. Hi, everyone. Hello. Hey. Yeah. So, one of your classmates noted that I should encourage you to come tomorrow to the pit at 3:30 to build a chariot, because there is a chariot race. Apparently, you build a chariot, you race it in Queen's Park. Apparently, from what I understand, Angsai has not won in 51 years. That is shameful, and you should go and fix it. I'll try to drop by as well to see how you're doing. Tomorrow's supposed to be warmer. So okay. So that's that. Yeah. So are we on the stream? All right. Okay. So okay. All right. So that's that. So yes. Will I ride the chariot? Well, like if you build like a crummy chariot like in the past 51 years, then no. But if it's a good one, like 51 years ago, then definitely yes, if offered, and it's good. Like a Roman emperor. Okay. Anyway, go build a chariot and stuff. Okay, all right. So I want to continue talking about C. So I know this is like not easy content. It's never easy content. And we have been talking for 2 hours now about it without like writing a lot of concrete code. We'll write some concrete code today. And starting from next week, it's going to become more and more concrete. But there is kind of like rules that we need to learn. Technically, we talked about those things in Python, but I know that those are not easy things in Python as well. We'll be reviewing the Python memory model too. So just like, please stay with me. It's like, it is just complicated, but it is what it is. So, okay. So to remind people what we've seen so far. So in C, you declare variables like this, right? So you have the types. So for example, you say A is of type int, and then you have literals if you initialize on the right-hand side. So literals just means data that you input into the program, and it could be as characters. So characters inside single quotes, or it could be something like strings, which we'll talk about in more detail today. That's on the right-hand side. So saying something like this just means like you have this box A, which is a memory cell. So put 42 into memory cell that corresponds to A. This works the same way, right? So the way this works is S is also corresponds to a memory cell. S is of type car star, meaning that S stores an address of a car. And really what S stores is where the character A is. And then A is the first character in the sequence that ends with a null. So we had the ampersand, which is address of. So if C is stored somewhere in memory, you can make it so that you know what the address of the variable C is using the ampersand. Again, the structure of this kind of thing is exactly the same as the structure of this kind of thing, right? So the variable here is P underscore C, and this variable is of type car star. Make sense? So car star, it's like just happens to be typed like this, where the type is car star, in the same way that here the type is long int. You can have types that, you know, have space in them. So essentially the type here is car star. Okay. So arrays work like this. So this is just like a review, and then we'll have one slide with a summary, and then we'll do the exercises. So the way arrays work is, so arrays are kind of like lists, right? You can initialize them like this. So you say int array, and then here we don't need to specify how many elements there are in the array because you initialize it. So it just figures out, okay, you gave 3 numbers, so it's going to be an array of size 3 integers. You can initialize it like that. You cannot do assignment, so this is just for initialization. You can also initialize an array with so declare an array without saying what the contents are. So here you're just saying, I want to be able to do like R2 at 0 up to R2 at 19 eventually. Okay. So that's that. So pointers, we've already kind of done that, but pointers go together with arrays. So I want to review that again. So if you have a pointer to A, meaning if you have P, so pointer is the same as address. So if you have something like PA, which happens to store the address of A, then you can say star PA, and that's the same as saying A. That was a lot of words. Does this not make sense to someone, like just as words? Yes.
How do you think you got rid of the star? Wouldn't it still be the address?
It would still be the address. Yeah. So let's do this now. So I'm taking this and I'm going to Python tutor. Okay, so this is just the code from the slide. I need to fix up the quotes. So the quotes in PowerPoint are like the round quotes. This is like the real quotes that you do in C. So let's see what happens here. So first of all, like we said, so A and PA and S, they're all the same kind of thing. So they're all local variables in the function main, right? So A and PA and S, they look the same. The difference between them is the type of value that they can store. So A stores integers, and then PA stores addresses. So if I switch to show memory addresses here, so the address where the 42 is stored is this. So this is something that C just decides when it runs the program, or the computer decides, whatever, right? So what we're saying when we're saying PA, which is of type int star, is the address of A, is we're saying, well, like whatever is the address where this 42 is stored, just put this address into PA. And that's what happens, right? So this thing just got copied over here. Make sense?
Yeah.
So now we are also going to put ABC somewhere in memory, and we're going to make it so that S stores the address where A is stored. So that's what happened. So ABC is now somewhere in memory, and A is stored at this address, and this address is stored in S. And now we're saying star PA is equal to 43. So what does star PA mean? So star PA means the value at this address. So this cell. So star PA, saying star PA is the same as saying A, because it's saying go to the address where A is stored. Yes.
Star P equals 43 and E equals 42 does the same thing.
Exactly. Yeah. So star PA and A, to the extent that PA is the address of A, are just interchangeable. Okay. So saying star PA equals to 43, what it will do is like it's the same as saying A is 43. So A is going to become 43. Makes sense? So the question from here was, well, like, what if I say something like PA equals to 0? I can say that, right? So what would happen? So when I'm saying A is equal to 42, what happens is the value 42 gets in here. When I say PA equals 0, exactly the same mechanism. What I'm saying is take the 0 and put it here. So this, which currently is the address of A, because we said PA is the address of A, this is going to become 0. Yeah.
But if the address of PA and the address of A are the same, then
They're not the same. The address of PA is this. The address of A is this. PA happened up until we said PA equals 0. PA happened to contain a number that was the address of A, right?
when we set when we look in address of PA equals address of A, we're just setting the value of A.
No, so we're setting the value of PA to the address of A, right?
Like literally the address.
Yes, 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 yes. Okay, so they are in the, so the question was difference between star and ampersand. So ampersand means address of, right? So when we're saying address of A, what we get is this, right? So what I'm saying here is take the address of A, so wherever A lives, store the address of A in PA. So it's like you're asking me, what's my office? I say like band 2028, you write it down in a note. That's what's happening here, right? So star PA is the opposite, right? So star PA says, go to whatever this address is and take the value there, right? So PA is like the address. So like the note that says band 2028, star PA means like go to my office and put something there or take the value from there. Yeah.
Can we go through what happened if we just said star PA equals A?
So yeah, so if you say so star PA equals A, so something like this, just star PA equals A.
Or even like initialize there.
So those are different. So star PA equals A is just doesn't do anything. That's like the same as A equals A. So this is just saying like take A and put A back, at least like before you said PA equals 0, right?
Yeah.
So when we're saying star PA, we're saying the memory cell at address PA. That memory cell, that's just A, right? So when PA is the address of A, then star PA is just the same as A.
Yeah, so what happens if we get rid of the ampersand?
So
Star PA equals 43.
that will give you an error. So and it doesn't matter where. So I think let me generalize the question. What happens if I say so? I picked 0 specifically so that it wouldn't complain, because 0 you don't need to explicitly cast. If you say star PA equals to 43, it's going to agree to run. It's going to give you a warning. And like, so So the reason that if you compile it, it's going to give you a warning. Here it just gives you, I guess that's a kind of warning. So the reason is 43 is not a valid address. So it agreed to store. So this is just 43 in hexadecimal notation. So it so we'll do hexadecimal a little bit later. So, but yeah, like this just says 43. The problem is 43 is not a valid address. So it agreed to do it, but it has like the skull thing. And then if you tried to say go to address 43, which is not a valid address, and put a number there, again, it's going to agree to try to run, but here what happened is it crashed. The reason it crashed, so here it says invalid write of size 4. The reason it crashed is that 43 is not a valid address. You're not allowed to write to address 43. So the program at this point just crashed. But this you can do. And what this does, in the same way that when you say A equals 42, it puts 42 in A, PA equals 43, puts 43 in A, but you use PA as if it were an address. So if you try to actually go to address 43, the program is going to crash. Make sense? All right, what's this quirk saying? Is it like all skulls there? Okay. Okay, so that's a good question. Yeah, so Quarkus, there's we're just using the old 180 page right now. I'll set up the web page and link it from Quarkus around today. So I noticed that in Python Tutor, the variables show up empty before going step by step. The C initialize all the variables before running the code. So the answer is it depends. So it's not specified. So this is like an advanced question. So the answer is it depends. So you can imagine a situation where you cannot really initialize variables before running the code. For example, if the situation is kind of like this, right? That could happen. You cannot like pre-initialize it. You have to run the function f in order to find out what the variable is. So the empty, it sometimes pre-initializes, sometimes not. The empty is just for Python tutor purposes. So the answer is it's complicated. Okay, that was an answer to Elia. Yeah. So you can assign it wrong type of variable, but when we run it, it will error. So in general, yes. So it's not so much that it's the wrong type. So 43 could have been a valid address. It happened not to be a valid address. Yeah. But
if you were to necessarily name PA, would that make the value of PA the address that would point to anything?
You mean this one? So no, so it's point to just means it's the address of. So when we're saying PA equals to ampersand A, we're saying make PA be the address of A. Okay.
Of the address, and it wouldn't like actually be the address, like, you know.
I do know what you mean. So the answer is, and we'll get to the slide today, hopefully that just summarizes that as well. So the answer is C sometimes is permissive in terms of letting you do things that don't really make sense. The answer is, to the extent that this makes sense, this is the same. It stores the address of A in PA still. It just stores it in an integer. And it's unclear what you would do with that, because you're not allowed to pretend that the integer is an address. So it's gonna do the same thing. It's still the right-hand side is the address of A. So to the extent that it runs, it is going to assign something to it, something to PA, but it's not really a thing that makes sense. Yeah, yes.
That integer, right, that address for integer, and then you put that integer like into like a pointer or something.
Yeah, you yeah, you can you can make it work, but let's not get into it. You're not supposed to. Okay, let's first do things the way we're supposed to, and then we'll kind of play around with it. Yeah.
Does every address that you initialize has their own address?
Every variable that we declare gets associated with an address. Yeah.
So you'll get a new address for the address for a variable.
Yeah. So what you're saying is if I have a variable that's like that, yeah, you can totally do it.
What do you need to do? Sorry.
Well, because PA is of type. So let's do one thing at a time, but just to answer your question. So PA is of type int star. So that means that the address of PA is of type pointer to int star. So it's like an address of an address. So this is the type, but one thing at a time. Okay. All right. So that was just in response to a question. Okay. So functions, so this is, again, just kind of to review, I think, I know I'm repeating myself, but I think this is like a little bit tough. So you can send a pointer, so you can send an address to a function, right? So the process here is like this. So here we have f, and we'll do the main function. So something like this. So what this would do is it would, so what we're doing here is we're changing the value of A. So here's how it works. Make a donation. Okay. So here's what happens. So we have main, and we have the variable A over here has the value 42. So what we're doing now is we're saying, take address of A. So take this guy, the address of A, and copy it to PA. Calling a function in C works the same way as in Python. So we copy whatever is here to here. So now what happens is we're saying, okay, so A contains 42, and then the local variable PA is the address of A. This is saying go to, so do star PA. So what does star PA mean? It means go to the cell at this address. And the right-hand side is 43. So it's saying to the cell at this address, assign 43. And that means that the value of A becomes 43. Does that make sense? Yeah. P underscore A is a local variable, yeah. So just like in Python, because p underscore a is a local variable, I cannot over here say whatever, like print p underscore a, or just like here, I just say p underscore a. Even that is going to crash, right? It's going to crash because pa in main just doesn't exist. So not crap, it's not going to compile. But that doesn't matter, right? So what we did here is we said PA here is the address of A, and we copied the address of A over here. And then here, it's not that we changed PA, it's that we went to the address that PA referred to and changed the value there. So it's PA actually remained the same. We didn't even try to change PA. What we did is we went to the address and we changed the value there. So the analog in Python here would be it's already 5. Would be something like this. So this changes L, right? Because you could say L and L1 are alias list. So to be clear, L has now changed, right? Does that make sense? So even though L1 was a local variable. So why is that? Well, that's because when you say L1 and 0, what you're doing is you're going to the memory table to the list L, which is the same as the list L1, and changing the contents. What we're doing here is the same. We're saying go to, not like change PA, but go to address PA and change the contents there. Going to address PA is the same as going to the memory cell where A lives. So let's do the diagram once more. So A is in this box over here. We're going to function f. And in function f, we're saying, go to this address, which is this address, and change the value to 43. So now the value of A, which is like in main, has changed to 43. PA right now exists. After the function finished running, PA doesn't exist anymore. It was a local variable, just like in Python. But the value of A is now 43 because the job of F was to go to the address of A and modify the value there. Does that make sense? All right. So, okay. So now that we have arrays, you can access elements of arrays in the same way that you access them in Python. But really what's going on underneath is you're using the star notation, so the dereferencing operator. Okay. So the way it works is like this. Sorry. Sorry, so we already did that last lecture, so I'll skip that. Actually, so we did the rules last lecture, so let me review it anyways. So all variables are declared. You can declare an array like this. Address of works like this. We already done this. So this, I do want to, okay, so I want to answer the question, but I also want to go through the slides in order. So let me do this in order and I'll get back to your question as well. So how does function calling works? The same way it works in Python. So what happens if you say F43, it doesn't even need to be a variable, it can be a literal. So what happens is this gets copied here. That's what we saw before, where the address of A was copied to PA. So what happens if you do something like this? Exactly the example from before. So you take the address of A, the address of A gets copied to PA. So what we saw before is if you say star PA, that will have an effect on A because going star PA equals whatever goes where A is and changes that. But just changing PA has no effect. Does that make sense? Yeah. No. So it doesn't give an error. It's the usual situation where you change the value of a local variable. It has an effect inside the function, but it doesn't have an effect outside the function. So this, again, won't give you an error, but what it will do is it will now actually change the value of A. Right? And that's because you're saying F address of A, that's the example from before. So PA is the address of A, and here you're saying go to that address, which is the address of A, and put 0 in there. Does that make sense? Okay, so now that we've done this, I want to go back to talking about arrays. So arrays and strings are both kind of blocks of values. So the way blocks of values work is if you have, for example, the string hi, then you might have h stored at this address, and then I stored at this address, and then the null, which always terminates a string, stored at this address. If you have an array of integers like 3 and 4, it's, again, a block of values. Now, integers take more space than characters, so they can be spaced out more. How much more, that technically might depend on the computer. But for example, it might be that each integer takes up four spaces, bytes, but we'll just say spaces. So maybe 3 is stored at 2064, and then 4 is stored at address 2064 plus 4. And then if you have another element, that would be 2064 plus 8. So the reason we're bringing this up is that you can do arithmetic with S, with things like S. So for example, if S is the address of the H, so if it's 1032, for example, you can compute S plus 1. And S plus 1 will be just 1033 because S is 1032. And you can then say, okay, like go to address 1033 and get me the value there. And that would be the I, right? Because at address 1033, you'll have I. Does that make sense? Yeah.
So with chars, or with cars, it's always like +1 or +.
With cars, it's always +1. Yeah.
But for integers,
Yeah, we'll get to that. Yeah. So to answer Michele's question, so pointer arithmetic, so if you're operating on a variable that's an address, doesn't work exactly the same way as kind of normal arithmetic. So if you have an array of integers, and then you say r plus 1, this would be actually 2064 plus 4 rather than 2064 plus 1. And that's because what C does is it makes it so that this kind of thing basically gives element number 2 in the array. So if integers take up 4 cells in the memory table, then r plus 1 is actually the address plus 4. So let's just do a few actual concrete examples here. So I'll just define an array. And I can print the address. Again, unfortunately, several things are going on here at once. We'll be kind of more ready to talk about things in a more linear way around Monday. I want to print the value of the array. So I can do it like this. But that will print it in hexadecimal, which we don't know how to read. So I can also print it like this, and this will convert it into decimal. And I'll also compute plus 1. They miss. You know, when you switch between Python and C, these semicolons sometimes give you trouble. Okay. So here's what it actually is. So here I'm printing array plus 1, and this and array plus 1 is this. So I printed this. Right, so this is just the same as this. So I said I want array plus 1. It printed the address of the 7. Does that make sense? Questions about this with me? All right. So here I just want to, so this is again kind of a weird hexadecimal notation. So if I want, oh, I forgot a new line here. Sorry. So I'll just add new lines here so that it's not all smushed together. So this is just this number, but in decimal. So this is the address. And now I'm printing array plus 1. And here it is this plus 4. Okay, are you with me? Does this make sense? All right. So that's like this. So array, you can use something like array 5. The point of the story for the last 5 minutes was you can say array at 5, and what that would mean is get me element number 5 in array. But really what C does underneath the hood is it converts it to star array plus 5, which is the same thing, because that's how plus 5 works in C. You take an address, you add 5, it says go to the address where the 5th element would be. That's just what it does. And it literally just converts any array at 5 to this kind of notation before compiling the program. For that reason, this kind of thing, array 5 is called syntactic sugar. So syntactic sugar is like elements of syntax, so elements of how you compose the program that just make it nicer without changing the underlying semantics. So you could imagine that C did not have the square brackets because it really doesn't. It just takes all the square brackets and it literally converts them to this notation before doing anything. Does that make sense? So syntactic sugar, for people who like sugar, that should make sense. It's supposed to make it nicer without changing the underlying structure. So it's really like syntactic saccharine because it's not bad for you. Okay. There's like a last use concept of syntactic salt. Of course, some people like salt, but salt is like the kind of thing that's supposed to make food like more interesting. So an example of so it's basically anything that constrains what you can say. So it's a little bit more debatable what counts as syntactic salt, what doesn't. You could imagine saying, well, like if I'm writing one function and I open a brace, like why do I have to have the final brace? Like the only thing that you could have at the end of the main is a brace. So why don't they just leave it out? So you could say like, okay, like the mandatory braces are like in some ways syntactic for the last function are in some ways syntactic salt. There's not like really good examples there. Okay. So this is unlike Python, which is not actually syntactic sugar, right? So there's not like a straightforward thing to which you can convert LS3 in Python. For one thing, because what Python does is it checks like, hey, like, are you actually, is there like an actual element 3 in L? And if not, I got to produce an error, stuff like that. C does not check it. C just computes this address, array plus 5. And if it's not a valid address, for example, if the array is smaller, the program is just going to crash. You won't know why. So, all right. So here's a summary of everything that we talked about up to now. And it is a little bit like what you see in calculus, where like the rules are not that difficult. Like this is all the rules. The complicated part is applying the rules. At the same time, there's not very many of them. I'm going to go through all of them, and then we're going to do exercises. Yes.
Question about pointer arithmetic in arrays.
Okay.
What if the elements in the array are like longer or like shorter? Because I remember you mentioned how like there are like some types like doubles are like longer than integers. Like,
yeah.
If you're doing pointer arithmetic to like go to the next address to like see know like how many memory addresses should go forward.
It does. Yeah, it does. So this is actually the example here, right? So usually integers take integers usually take up 4. So for that reason, array plus 1, if it's an array of integers, that's plus 4. On the other hand, cars take up 1. So s plus 1 just is like actually plus 1. So depending on the type of the pointer, it's going to advance by different amounts. It knows how much to advance by looking at how much the car takes up, how much the int takes up. All right, other questions? Okay, yeah.
It says their star PA plus I is the same as PA at I.
Yes.
Summary.
Yes.
Is that only 4 blocks of values, or can you do that with any point?
It's you can do it with any pointer. It's literally the same. So what the C compiler does is before it compiles anything, it's like a find and replace kind of thing. It just like replaces any of the occurrences of the square brackets with the star. So it's not like the usual style, but yeah, you can totally do it. So to give you an example. So here I'll do like int A is 42, and I'll say int PA is address of A. I'm busy. And you can say PA at 0 is equal to 43. That's the same as star PA plus 0 is equal to 43. Like those are literally the same.
If you charge PA at 1, what would happen?
It would probably crash because it's not a valid address. So in the same way that if you do, like again, like so C allows you to do anything, right? So like you can say like whatever, like we said, like PA is like whatever, and then like star PA is equal to 44. That's valid, but that's got, unless I got like really lucky, it's gonna give you a skull there or something. So yeah. Oh, I didn't. Yeah. Yeah. So that's actually just like not compiling, but that's the skull face. Yeah. Go ahead.
So in line, what is it, line 9, what if you said star PA at 0?
Line 9 start. So star PA at 0. That's again the same kind of thing. So the question was like star PA at 0. So that would just not compile. And that's because that's because PA is in stars, so you can star it to get the value at it, but you cannot just say like any random integer address of. So that so the type checking we'll do later. Okay, all right. So I think we'll go through the rules next time, and then we'll do exercises. Tournaments. So the results for what I gave people in terms of the bonuses for the Pong have been on Gradescope for a while. If you haven't checked how you did, you can do that. However, we'll have an in-person tournament with new prizes and also awards for everyone who won on Monday. So gonna be fun. All right. And Chariot tomorrow, 3:30. I have no idea what any of that means, but I'll also maybe come check it out. See ya. Bye.
Are we gonna get our thematic similarity mark back?
You did. Okay.
I don't think that is. I don't 2 days ago.